Hi everyone, hope you're having a good day. What I'd like you to do for today's lesson is complete numbers 1 through 5. This is a different lesson that was in your packet. Remember, we reconstructed it. So 1 through 5, then unpause to check the answers. All right. Take a look at these answers. We'll debrief them in a second, but I did make a funny typo that I gotta fix. That should be retrospective, not active. So your answers may vary on question 4 or on question 3 and 5. So don't worry, and 2 even. You can say that in a bunch of different ways. But basically the overall gist is that we did just look at a retrospective study that happened in the past. And so it could be that there was some hiring bias or hiring discrimination going on, or it could be that there are other factors involved. And so we don't know because it was a retrospective study that we just looked at data that was already collected. We didn't do any sort of manipulation of the variables. So what could we do to try and prove that women are being discriminated against in the field of STEM? Well, we can look at what you guys did in the Desmos activity the other day. So in the Desmos activity, we asked you guys to rate resumes. We randomly assigned you to one of two resumes. The resume either said John Miller or Jennifer Miller, and everything else about the resume was exactly the same. Now, this data that we're looking at comes from the actual John-Jen study, which was done at Yale, but I don't have your Desmos data yet to put here. But we're just using that data to show what could have happened in Desmos, because this is what actually happened in the Yale study. So the professors who saw John rated John at a 3.78, and the ones who saw Jennifer rated her at a 2.93. But remember, they were the exact same resume. And so now we have more evidence to conclude that there was hiring discrimination going on. So in this case right here, was this an observational study or an experiment? You guys participated in an experiment because the we teachers controlled which resume you saw. John or Jennifer. So we weren't just looking at data that was already collected, we actually controlled that. So now I want you guys to go ahead and try 7 through 12. And when you're done with 7 through 12, unpause and check the answers. This is all about the Desmos activity that you did. So you're going to describe the key elements of the Desmos experience that you had. All right, so here are some of the answers for you to look over. I'm going to just zoom out for this 7 through 11 for you to see. You can pause to check. And then we will debrief by going back to number 1 for some vocabulary, etc. And you can look at number 12 here. So you can pause to make sure you got the right answers. We'll go back to number 1. This should say faculty. Love making typos. Okay, so let's debrief some with number 1 with our red pen. A couple things about this. First, prospective study is when you collect data moving forward. So you follow a group into the future. And then retrospective is using already collected data from the past. And so both of them are called observational studies because it involves not manipulating the variables, just observing what's going on. which we'll talk about in 1 second. So we could have some real discrimination going on, or there could be other factors involved. Remember, this is correlation. Does not imply causation. We learned that in our last unit. And so there could be other factors. Those other factors have names or alternate explanations, and those are confounding variables. So, confounding variables is the definition of the other factors or the alternate explanations. So maybe women weren't encouraged to pursue STEM at younger ages, and so when they grow up, they're just not interested in doing it. And it's the socialization that affected both their interest in STEM and whether or not they applied for the jobs in STEM. There's lots of different things you could say there. Moving on to number 6, an observational study is when you simply just observe without controlling. And then in an experiment, we have treatments imposed. You cannot establish causation with an observational study, but you can with an experiment if you've done it properly. So we controlled which resume you saw. We said, oh, you're going to see resume 1, you're going to see resume 2, et cetera, et cetera. And so that was manipulating the variables from the researcher's end. Okay, we have a couple of vocabulary words to write down here. Participants of a study are called experimental units. Remember, the explanatory is what's manipulated. Another word for that is a factor. And then we had 2 treatments, which were John and Jennifer. Those were the treatments, the 2 different names. Then the response variable is what's being measured. These are the same words that we used in our last unit. What elements were controlled? All the students saw the exact same resume. So control is one of the principles of an experiment. So control and then assigned randomly is another principle. And then, did you know you're participating? So you might have heard these words before. This was called a blind. No, so that was a blind study. You were blind. Now, when I looked at the results, I knew which ones you saw, but it wasn't necessarily double blind yet, but it was a blind study in general. It involved being blind, where someone was not aware. Say participants unaware of which treatment they were given. So they're doing randomized controlled trials right now on the coronavirus vaccines, and people are being given a placebo or the treatment, or maybe a different level of the treatment. There's a bunch of different levels, but they don't know which ones they're being given. So that is what makes it blind. And then when they measure how they're doing, sometimes the researchers don't know what the people received as they're recording the results, and that's called a double blind study. So did everyone see the same resume? How many were there? We have 380 staff students. So you always want to have at least 2 treatment groups. And so we had to have 2 resumes. We didn't just give a woman's resume out there and say, oh, people didn't like her. We need to have something to compare to. And so I'm going to add comparison. It's very important. And then also, when we have 150 people looking at each one, there should be more than 1 participant in each group. Which is called replication. Okay, and then this one we have, does the experiment prove? So the only difference between the resumes was the name. And so we know now it was the name that caused the ratings. And so you can establish causation with a well-designed experiment. So that's one of the things in the news right now as well, is that people are saying, oh, do masks cause the particles to get in or out? Do they reduce by causal relationship the transmission of coronavirus, et cetera, et cetera? And so you have to do a controlled experiment in order to say whether that's true. Many of the things people are citing are from observational studies, and so we need to actually control the variables and make sure it's actually the masks themselves that are working or not working. Okay, number 12. Here we just have some vocabulary from a real study. This is the Yale study done. Randomized double-blind study. So I just wanted you to identify that stuff. And then this was our sample size. And so randomized double-blind study I just wrote here. Then we have 127 total faculty members. That's our sample size. And then they were randomly assigned to the groups. And they were given a random process. So this is called, another name is called a completely randomized design. It's one of the types of experiments that we do. And so I'll just show you a quick little outline. So we had 127 participants. I'm gonna change that to faculty. So this is the outline of the experiment. And then we put them into group 1. I'm gonna do a little actual random assignment. So we use a random method like a random number generator to assign them into group 1 and group 2. They tried to do half and half. If you read the actual paper, then we have n equals 64 and then n equals 63, like trying to be half and half. And then group 1 got John, and group 2 got Jennifer. I don't know exactly which one got which. This is just an example of the outline. And then we'll say evaluate John and evaluate Jennifer. And then at last thing we do is compare hiring ratings. And so that's just an example of a little outline that explains exactly what this study did to do the experiment. So what I want you guys, oh, that was number 12. So what I want you guys to do now is take a look at these notes, which there are a lot. So go ahead and pause your video so that you can copy all of this down into your notes box. We're still using the notes box from the packet, the original packet. We just had a different activity to start. So you may take out that notes box to write these notes down. Okay, so hopefully you were able to get all these written down. The difference between observational study and experiment are very important. So make sure you know that the main thing is that we have treatments imposed for an experiment or not for observational study. We have the same vocabulary words we used before, but we have some synonyms: factor for explanatory variable, and then level for the different treatments that each person receives. Response variable is what we measure. Confounding variable could affect the results without being measured itself. And then we have these 4 principles of a well-designed experiment. This one type of experiment that is really common, and then a control group and a placebo are something that you guys need to know about. You've heard the word placebo. I've even heard it a lot in the news lately about the coronavirus. So they're giving a placebo to people and then the actual vaccine to others to see if the vaccines that they're developing are actually effective or not. And they might have a response to the placebo, And so that's why we have to have double blind. So I'm going to put a little note like, why we blind when possible. Okay, so now I want you guys to try. There's 2 check your understandings today because we kind of combined 2 lessons here. So go ahead and try both. If you'd like to try one and then unpause the video and try the other, that'd be fine too. It's your choice. So give it a pause, try the check your understandings, come back and check your work. Okay, here's number 1. This was an experiment because they expressed that. Remember, you can pause at any time to see the answers. Here's number 2. And then here's number 3. I do want to adjust something about number 2. I'm going to add in red. It's important to be really specific, so I'm going to add that note. I wasn't specific enough, so I would correct myself on the test. And then remember, correlation, observational study cannot establish causation. Okay, then we have our last check your understanding. So if you tried it, great. If you didn't, pause it before you check. And then here are the answers to that, A, B, and C. And I'll make a little note about B. You have to be very specific here as well. Notice how I said assign them to the display group. And then we said assign them to the chart. And then we said get the remaining 20 get nothing. So you have to be clear about which group gets which treatment. Okay, and then random assignment balances the effects. This is a good thing to just say all the time. And then here's a quick overview of the outline. Okay, and then to end class today, I have a quick little meme I want to show you guys because it's Halloween is coming up, and this is just really funny to me. So we talked about randomized controlled blind trial where we get different placebo and stuff like that, where people are unaware of what they're being given, and some of them it's just a sham treatment or one that's not real. And so this funny little tweet made me laugh where it says, what idiot called it a randomized clinical trial controlled with a placebo and not trick or treatment? So think about it like that. The trick is the placebo, and we call that sham treatment. And then treatment would be like the actual active ingredient. So anyway, I just thought that meme was funny and appropriate, timely for Halloween coming up. Hope you guys have a great day. Thank you, and I'll see you soon.